All right, welcome back. In this video, we're going to cover the second example from section 3.3. This one should be a bit shorter. The last one we had a lot to go over and all the little details of how everything worked. But this example, example 2, does have a different form. So in the last example we did, let me scroll back, it was a constant squared minus x squared, and this is backwards. This is x squared minus a constant. So if we go back and look at the warm-up, when you have something squared minus a constant, that's going to be like what we have here in C. And notice the key to simplifying that is that we had to have the same constant in front of the secant as we did by itself so that we could factor that 16 out of both terms. And there's going to be a problem with that here because notice the constant in front of the x is 25 and then the constant on the other side is 4. And those mismatch. They don't work. So what we need to be able to do to simplify this, it would be nice if we could somehow get this to be 4 secant squared theta minus 4. That's what we need to get it to. So really, I guess my question is that if we want to integrate the square root of 25x squared minus 4 over x dx, what would we have to let x be? So what would we have to let x be in order for our square root part, that 25x squared minus 4, in order for that, we need it to look like this. What would we have to let x be? And remember, we're squaring it. It's not x, it's x squared. So we know part of it has to be secant, because when we square secant, it's going to be secant squared. And we need the 25 to cancel. Well, what squared is 25? It's obviously 5 squared, right? So we want a 5 in the denominator so that when we multiply it by, when we square that 5, it becomes 25. And then when we multiply by 25, those cancel. And keep in mind, remember, we want to finish up with a 4. And what number squared gives you 4? Well, that's 2. So my proposal is that we let it be 2/5 times secant theta. And then just like always, we need to find dx. So that's going to be 2/5 times secant theta, tangent theta, d theta. And so that's the first part. Remember, the second part is on the side, we're going to simplify the square root. So we have the square root of 25x squared minus 4. And when we plug that in, sorry about that. When we plug in our x, that's going to give us the square root of 25 times 2/5 secant theta squared minus 4, which is going to give us the square root of 25 times 4 over 25 secant squared theta minus 4. And then the nice thing that happens here is that the 25s are going to cancel, so the 25s cancel. And that's what I was talking about before, which is going to give us the square root of 4 secant squared theta minus 4. And now, of course, we can factor out the 4. So we have the square root of 4 times secant squared theta minus 1. And that secant squared theta minus 1, using the trig identity, becomes tangent squared theta. This is 4 times tangent squared theta. And then we take the square root. Square root of 4 is 2, and we're going to assume that, again, we have no limits, so we're going to assume that this absolute value of tangent theta is just equal to tangent of theta. Or, sorry, 2 times tangent theta, I should say. So we have 2 times tangent theta. And that's everything we need to know to go ahead and rewrite this integral using our trig substitution. And so I'm going to go ahead and rewrite that. I have the integral. We just found what that top square root was equal to. We said that was equal to 2 times tangent theta. So we have 2 times tangent theta over x. But of course, x again is, that was what our substitution was. That was 2/5 times secant theta. And then from our substitution, we found what dx was. So this is times 2/5 times secant theta tangent theta. And most of the heavy lifting is now done. We can simplify. 2/5 are going to divide out. That secant is going to divide out. And that's going to leave us with what? What do we have left? This looks like the integral of, we have a 2. I'm going to pull that out in front. We have a tangent theta and another tangent theta. So this is going to be tangent squared theta, d theta, which is not an integral that we readily know the antiderivative of, but we do know secant squared. So using the trig identity, right, we do have a trig identity. We know that tangent squared is equal to secant squared theta minus 1. We actually did that over here, right? We know that tangent squared theta is equal to secant squared theta minus 1. So we can do that here, actually. That would be helpful to us. So we have 2 times the integral of secant squared theta minus 1 d theta. And now we're in business. Because what is the antiderivative of secant squared theta? That's right, it is tangent theta. So the integral of secant squared theta is tangent theta. So we have tangent theta, and then the antiderivative of -1 is theta plus our constant. And then we're going to use our right triangle. So let's go ahead and draw that. We have our right triangle. We know that our substitution said that x was equal to 2/5 times secant theta. And we want to put this in a form that is going to be a little bit easier to work with for a right triangle. So this fraction is no good next to the secant theta. If we multiply both sides by 5/2, it's going to give us 5x over 2 is equal to secant theta. And then for right triangles, we're usually used to thinking, instead of secant and cosecant and cotangent, we're usually used to thinking in terms of sine, cosine, and tangent. So if you'll recall, which function is the reciprocal function for secant? Is it sine, cosine, or tangent? And if you said tangent, or let me see, if you said cosine, you would be correct. So cosine theta is the reciprocal of secant theta, which means if we're going to change this to be in terms of cosine, we also need to take the reciprocal on the other side. So if secant theta is equal to 5x over 2, cosine theta is equal to 2 over 5x. And again, cosine is the adjacent over the hypotenuse, so that means the adjacent side has to be 2. The hypotenuse has to be 5x. And it means that that missing side is going to be 25x squared minus 4. And we now have everything we need to be able to rewrite this in terms of x again. So let's go ahead and do that. This is equal to 2 times tangent And tangent is the opposite over the adjacent. So the opposite side is square root 25x squared minus 4 over the adjacent side, which is 2, minus theta. And we need to do some pre-calculus for that. So well, we can actually, rather than working off that first line, why don't we just work right off this line right here, right? So if we solve that for theta, theta is equal to the inverse cosine of 2 over 5x. Inverse cosine of 2 over 5x. So this is minus the inverse cosine of 2 over 5x plus c. And we can distribute our 2 in, which is going to give us the square root of 25x squared minus 4 minus 2 times the inverse cosine of 2 over 5x plus c. Final answer. There you go. Let me know if you have any questions. Thanks again.